Excellent. All right. Well, welcome, folks. I see that we've got a few people on here. Feel free to tell us where you are joining us from. Feel free to tell us what your favorite planet is, or maybe even a favorite galaxy, or just favorite object to look at in the night sky. Maybe you just love looking at the moon. That's always a fun thing to check out. My name is Erik Johnson. I'm the director of the William M. Starkle Planetarium at Parkland College. Waylena McCully is the producer at the planetarium as well, and we are showing you our spring prairie skies. Okay, and what we generally do during these shows is we just give you a view of what you can see in the sky in the evening, so you can get a taste of what you might go out and look for on your own. And maybe we'll show you a couple of objects that you might not be able to see from your own backyard. So those are a couple of things to think about. I believe actually this is International Dark Sky Week. Is that right? Yeah. So there's been a lot of considerations and promotion of such events to make sure that you look around and make an effort to try to help preserve the dark skies, meaning looking at proper lighting conditions, as in having light bulbs and lamps that would actually point the light downwards to help preserve a sky where you can actually see more of the stars and maybe even see the Milky Way without having to travel for a long time. Oh wow, Barbara has given us a great address. Barbara tells us that they're in Urbana in the Andromeda Galaxy. Excellent. Okay. I didn't know Urbana was in the Andromeda Galaxy. Did you know that, Waylena? Oh, wait, I'm sorry. That's not an address. Barbara's telling us what their favorite object is. I completely forgot. I didn't know Urbana was located in the Andromeda Galaxy. I thought it was a shorter trip. Oh, that's fun stuff. Okay. So, oh, interesting. I have to change my landscape for a moment here because I always like to show the planetarium on Stellarium first. So let me go ahead and get that loaded up in just a second here. Always good to misinterpret some person's point on the chat. That's really fun stuff there. At least Barbara seems to be tickled by it. That's good. All right. So,
well, she has good taste in galaxies.
There you go. It is a nice galaxy and historically very important because it helped revolutionize our understanding of the universe. All right. So let me finally share my screen. I'm popping up a free piece of software called Stellarium, one that's actually pretty customizable. When you open up this software yourself, you would not necessarily see the planetarium on it. You would actually see some other types of landscape. What Waylena did was she took a number of photos with her 360-degree camera and using some photo processing techniques that she knows, she was able to put together a skin of this that she helped get me to upload into this software so that I can show the planetarium whenever I open this software up. So it's a lot of fun that I can share that with you in this fashion. Waylena, I believe we actually have these images. Do we have them available on our website? I don't recall right now off the top of my head.
I don't know. I will look for that.
Okay. Your intent was always to share these with anybody, so
it is. But to share it properly for Stellarium needs to be packaged with a couple other files. So I don't know that we have that.
Gotcha. Okay, well, another thing for another time, and we can check that out. We've got a number of your projects that we have put up on there, like the virtual backgrounds that both you and I are using right now are up on the planetarium website. So when you folks are on Zoom yourselves, you can show off the planetarium whenever you like. You'll notice,
Erik, I'm going to interrupt because I'm going to say hi to John from Bay City, Michigan.
Oh, wonderful. All right, and John has a really
very dear old friend.
Wonderful. Welcome, John. All right. Excellent. Well, thanks for sharing that stuff there. All right. So looking at Stellarium, I see that we've got the sun actually behind a few trees. I'm guessing those trees are going to get in the way of a lot of the stars that we'll be looking at. So I'm going to change my landscape one more time here, and we're going to go out to a local observatory. This observatory is run by an affiliated group with us, the Champaign-Urbana Astronomical Society. They named this observatory Prairie Winds, and I have felt those prairie winds out at that observatory from time to time. Being out in the middle of the farmland, it can blow quite strong. So it's good to have those buildings protecting the telescopes that are out there. One other fun thing to note is that while they love sharing this building with the public, they've been throughout this pandemic not been able to do that sort of thing. So they're actually going to have some virtual events of their own. On next Friday, they're going to hold a virtual family sky watch at roughly about this time. So they'll show you some stuff there, a little bit of what you can see in the sky, and also the members are going to show you some of the cool things they do with their instruments. So always getting to see what people sharing their hobbies. So if you want to join them that Friday, feel free. I think I'll share that on the Planetarium's Facebook page as well, just so you folks are all aware of it. All right, now I'm going to do something a little crazy, something that I have not done during one of these shows before. I'm going to kind of go a little inside baseball with all of you. All right, so first off, I pulled away the ground. I know, it's very strange. Now you're actually just floating up there. And you have nothing holding you down. So that's a little bit of a problem. Now I'm going to do something even worse. I'm going to just pull away the atmosphere. And I have just kind of ruined everything with what we're seeing in the sky here. Now, there are a few things that are right next to the sun at this very second. And to show you what they are, the ones that I'm looking for, I'm going to press this button. So you see, next to the sun are the planets Venus and Mercury, and you see the moon. If you've been looking around over the last couple of days, wondering why you've not seen the moon right after sunset, this is a major clue as to why. The moon has been rising very, very late in the evening, after midnight, as a matter of fact. And now it looks like today the moon rose only maybe an hour or two before sunrise. So you might have only seen a very, very thin crescent to the moon. And then seeing Mercury and Venus this close to the sun tells you why you're not seeing those planets in the evening sky tonight. Okay, if you've got clear skies out where you live, you're not going to see Mercury or Venus very easily, because they're either coming up right before dawn, or you'll see them setting right after the sun does at sunset. So Venus and Mercury are not objects you'll be able to see in the night sky tonight, simply because of how close they are to the sun. And this happens with those two planets very often, but it happens with other planets from time to time as well. And I just wanted to give you a little bit of a view of that before we go further. So let's go ahead and give you a more natural view of things. I'm going to take off that label, because, you know, when you look up at the sun usually is not wearing a name tag. Okay. It would be very nice for the sun to do that, but I think its brightness tells you what you're staring at. Just don't stare too long, as always. Okay, so we are looking at the sun just about to set, and this tells us we are looking in the western sky. If you're curious about the exact directions you're looking, I can bring up cardinal directions. Looks like the sun's a little bit north of west. That tells you we're in the spring. All right, the sun's going to continue moving a little bit farther north as we go through the next couple of months until we reach the first day of summer, the summer solstice. Okay, you look around here, you can see the northern sky, you can see the eastern sky right there. Not a whole lot to check at this moment, but let's go ahead and let that sunset now. All right, lots of stuff coming in. Now, this is a lot more stars, and the stars are going to be a lot brighter than what you're going to see certainly in your backyard. And it's also probably a lot brighter than what you'd see if you were actually out at one of these observatories. I do this because on Zoom, I always am worried about how nice this image looks on your end. So just to help with the resolution, I just we inflate the brightness of everything. But you know, it's good. It helps you all see everything because I want you to get a sense of what you should be looking for. So if you're curious about the time we're at, this is at roughly about 9 p.m. You see it says 2054 right there, 8:54 p.m. tonight. So if you're looking out over here in the southwestern sky, you see some extremely bright stars and some very famous objects to check out. Ah, good. So those are your actual Stellarium files. Yeah, all right. So you folks, if you follow that link that Waylena just posted in the chat, you'll be able to download some of these files that she uses for Stellarium right there. So you can customize this on your own if you've got some space on your computers. All right, I'm going to go ahead and draw a couple of lines because I always like doing that before I just show it off right here. Let's see if this works correctly. Oh, I've got a red line this time. So we see these 4 bright stars right there. We've got 3 bright stars in a line right here. And this is one of the most famous constellations you can find right there. And that constellation is known to most people, well, to most Americans, as the constellation Orion. Okay, you see Orion's belt right there. Now you see the name Orion. The software actually gives you a neat piece of artwork. Normally in this software, you actually would see it in more of a in a black and white, a grayscale type image. But Waylena showed me how to get the color artwork up there because it's just, you know, it's so eye-popping. It's always nice to see that way. All right, Orion is the hunter right there. The bright stars that you see in Orion, the one that I've selected actually has a name that a lot of you might be familiar with. This one is known as Betelgeuse. All right, maybe some of you saw that movie several years ago, Beetlejuice. He got his name from this. Should I say the name a third time? Well, I'll just keep moving on. The star on the right foot here is known as Rigel. That's another really bright star in Orion. Another cool thing to find in the constellation Orion, right below the belt, you see this bright kind of fuzzy object there. Let me put that in the center and I'll zoom in on that area and let's see what's going on there. Oh, look at that. You can see what's going on a little bit more. Stellarium actually offers a couple of photographs that are set up on the sky there. Let me dim the stars for just a moment so you can see those images. This object is actually bright enough that you can see without even the use of binoculars. But if you can get binoculars or even a low-powered telescope to look at this, it is worth a treat. You are looking at the Great Orion Nebula right here. You can see this lovely color of reds, purples, and blues. The reason why this nebula is glowing in this fashion, there's gas and dust there, and that gas and dust, it's helped form some stars. Those stars are very hot, very bright, and also actually very young. And the light from those stars scatters off of that gas and dust. It glows blue for that reason. It heats up that gas, and it actually strips away electrons from those hydrogen atoms. And when the electrons combine back with those atoms, they glow that red color. So it gives this nice, you know, almost a magenta hue, maybe a purple if you want to describe it that way as well. It's just a really pretty thing to look at in the sky. And that one is really bright because it's basically the closest star forming region to us. Okay, so that's the constellation Orion right there. Now, if you want to see a cluster of stars that did that sort of thing that the Orion Nebula did several years ago, all you have to do is take Orion's belt and just draw a line. And let's go ahead and do that. We're going to draw a line from Orion's belt off to the right, and we head right over here. We've actually gone through 2 clusters right here. One of them makes this V shape right here, but the other one is a little bit more compact, and people focus on that one a lot more. I was out with students showing them the night sky in the last couple of weeks, and it was really easy to see that cluster of stars up there. All right, so let me go ahead and clear those out so that I can focus on them a little bit better. So we'll start with this fella here. I'm going to take off Rigel's label here for just a moment. There we go. We'll zoom in on that cluster now. Here we go. Here comes another picture of the sky. So we see lots of bright stars here. Those bright stars, some people, when they see it, they almost think it looks like a tiny dipper. You're familiar with the Big and Little Dippers. I've heard people accidentally think that this is the Little Dipper right here, but it's a lot smaller than that. What you are seeing here is often referred to as the Seven Sisters. But when you go back to the Greek or Latin name, it's referred to as the Pleiades. Okay, you'll notice also there's actually another name that's up here. For those of you who like certain cars from Japan, that car company Subaru got their name from the Japanese name for this cluster right here. Notice that surrounding these bright stars, there's a bunch of dimmer stars. There's actually over 1,000 stars in this cluster. And plus, you can actually see more gas and dust. So this is a relatively young cluster, so you can actually still see the gas and dust surrounding these stars. They have not quite dissipated all of that gas and dust. They haven't blown it all away with their bright lights and stellar winds there. Okay, so maybe in a few million years, the Orion Nebula would look like this. Just an interesting thing to imagine. I don't plan to stick around for that long, so that's just the way that goes. All right, the Pleiades, you're seeing it connected actually with the constellation Taurus. That V shape is meant to represent the bull's head. You can see the bull's horns right here. And the rest, yeah. And you do see one bright star up there. As a matter of fact, that bright star is actually closer than the other stars in that cluster that form the head. So it's a lot closer than those in the sky. All right, you might have noticed another really bright star off to Orion's left. And you can see that from Orion's belt, all you got to do is just kind of draw a line off to the left and you can find it. It's an easy star to catch up there. And let me go ahead and turn off all of those things. I like to not give this away quite immediately. So I'm going to click on that star. I think I've got its name there. There you go. Its name is Sirius. This is actually the brightest star in the night sky. All right, you really can't miss it. The constellation it's a part of, well, I really like how Stellarium connects the dots right there. That does kind of look like an animal. What kind of animal in particular? Well, you know, here you can see a dog, okay? I'd say that's pretty representative. Sirius is known as the dog star because it's in the constellation known as Canis Major, which just means big dog. There you go. Okay, so there's Canis Major, the big dog. All right, so those are the really bright objects that you'll be able to catch right over there in the southwest, but there's one other object that I know I missed. Looking up here at this artwork, I see right between the two horns of the bull, there's something reddish up there. Let's go ahead and zoom in on that and see what it looks like. If you see this object in the night sky, I'm going to give you one suggestion for when you find it. You'll see that the bright stars that I pointed out earlier, they will all twinkle in your evening sky. This object will twinkle as well, but not nearly as much. And the reason why is because it's in our solar system. It's not a star that we're looking at here. Okay? So let's see if I can get closer and closer to it. Oh, okay. Looks like there's a really noticeable dot right next to it. That's actually one of its moons. You are seeing a disk here. Stars don't show a disk because of how far away they are. You are seeing what we often refer to as the red planet. This here, folks, is the planet Mars. Okay, it's the planet that we can most, you know, it's not the brightest planet that you'll see in the evening sky, but it's one that we have a very nice affinity for because you can see it a lot. It can get pretty bright when it's very close to Earth. At this moment, it's actually getting pretty far away. It's getting a lot closer to the sun in the sky. It's setting earlier and earlier in the evening. But I'm guessing you've probably heard about Mars in the news lately, haven't you? Yeah, well, we just landed a space probe onto the surface and it's moving around on the surface. Its name is Perseverance. And in addition to that, in the last couple of days, it actually deployed something just underneath it. Okay, it deployed an object that is going to perform a test, a helicopter test. This will be the first powered object to fly on above the surface of another world that humans have ever set up. They've had things land on these surfaces, but they've never had actually anything take flight. So this is actually more of a technology demonstration they're going to do with Ingenuity there. Let me see, do I actually have that video? I should have actually brought that up because I'm now inspired to do it. Let me see if I can bring it up quickly. I'm just so excited. Let's see here. Nope, I can't find it quickly enough, but I wonder if this would do it itself. Oh, not seeing a whole lot there. Okay, oh well. I guess I should have brought that up more quickly. That's how it goes. Oh, is that it? No, that's not it.
Well, for anyone who likes coloring or has kids around who enjoy coloring, on our Planetarium website, we have some coloring pages, and there's a one for the Mars Ingenuity helicopter, and there's actually quite a few more. I'll go ahead and just put the link to the where you'll find all of the coloring pages that we have.
Excellent. Okay, I'll switch over. I just found the object. Thanks everybody for your patience. So NASA set up a nice animation to show what this thing might look like. Okay, and I'm really hopeful that this is going to work here. So here is the video. You folks can see the beginning of it now. Like I said, this is a technology demonstration. This has never been done before. They tested it here on Earth with atmosphere levels comparable to what is on Mars. Mars has a much thinner atmosphere, lower air pressure than what we have on Earth, and it flew very well. What Perseverance did a few days ago was it backed up away from the helicopter just to give it a flight area. And on Sunday, it is going to float for about 30 seconds. Do you remember how high it's going to get up there, Waylena? It's only going to be a meter or two. But later on, it will, if things go well and they feel confident with it, it's going to fly around over the surface of Mars and start to take photographs like what you're seeing right here. We're really excited about this. It was able to lock its rotor blades in place and they were able to spin. It was a very slight motion there. And we're going to start to get this data to see if this test was successful starting very early on Monday morning. So if you want to watch the live feed of that from Jet Propulsion Laboratory, feel free to get on there at 3 a.m. on Monday. I think it's 4 a.m. Eastern time, so it's not nearly as early for you folks, or late. It's really middle of the night, so it could be either way, couldn't it? So yeah, that's a technology demonstration that they're doing with Ingenuity on Sunday. That is really exciting to see what's going to happen there. All right, let's go back to the other one. Okay. Yeah, I see you shared your resources with from Cosmic Quest. That's fantastic. So that's what Ingenuity is going to look like. We're really excited, and I look forward to seeing what it's capable of doing. Because if it is successful, just imagine if we get future missions to Mars, there might be more aerial type missions that they will have, flying around, and maybe we could have aircraft on Mars in the future. I love that idea. Let's go ahead and zoom all the way back out there. Whew, zoomed out way too far. Okay, let's go ahead and turn off all that stuff there. So yeah, Mars is over there in the southwest. And if you don't catch Mars tonight, Mars might be in a slightly different spot. I want to show you an example of how you'll see it's in a slightly different spot here. So here's where it will be tomorrow, and on the next day, and on the day after that. So that's another way that people saw how planets were different from stars. They were able to see them actually moving relative to the stars from one night to the next. So if you were looking at Mars back in February, you would have seen Mars right next to the Pleiades. But nowadays, Mars is up by the horns of the bull. Okay, yes, Mars on the move. Perfect way to describe it. All right, let's head over here. And I want to point out something that will help all of you with orienting your sky. I said we were looking in the southwest, but if you're ever not certain and you don't know exactly which way you're looking, maybe you got yourself a little lost, I do always want to make sure we point out the easiest way to find our directions if you're on a clear night sky here in the Northern Hemisphere. So what we always do with this is we want to find the Big Dipper. The Big Dipper is the easiest way to help you find all of this. Big Dipper is actually kind of upside down right now. Yes, that's right, Zeppelins. That would be fun. I wonder how well that would work considering the extremely low atmosphere there. So that's a really good question to consider. But then again, the atmosphere is a little bit more, has more dense gases because it's mostly carbon dioxide. It's a really fun thing to think about. All right. So there you can see the Big Dipper. Probably looks a little bit backwards to all of you because it's kind of upside down. There are times every single night where the Big Dipper will be high overhead, but upside down. So that's what we'd be seeing tonight at about 9 o'clock. Okay. Let me clear out those drawings. The reason why I did that drawing here instead of clicking on it is because the Big Dipper, while you might call it a constellation, if I click on here, you're not going to just see the Big Dipper in this constellation. That's the star Dubhe. And when I connect this, notice that there's a lot more stars in that part of the sky. That's because the Big Dipper is part of a much larger region of the sky that you can see right there. And the artwork is not going to show you what you might think of when you think of a dipper. Maybe you think of it as a spoon, or you could see it as a frying pan. I know Waylena is seeing it as a frying pan right now. You probably see those eggs fried up over easy on there, huh? Okay, so you might see it as that. Maybe you see it as a ladle or a drinking gourd, okay? But when the Greeks and the Romans were seeing this, they saw a bear with a very anatomically inaccurate tail. And they gave it the name Ursa Major, which just means big bear right there. Okay. So when we talk about the constellation, we're referring to Ursa Major. And then the Big Dipper is just a known pattern of stars there. Floofy, perfect, is a known pattern of stars that you see right there. Astronomers will call that an asterism, but I promise you, you're not going to be quizzed on that. Okay. So in the Big Dipper, you've got Dubhe here and this other star Merak. They're very useful for us because they're almost perfectly lined up with this star over here. And that star is the North Star. It's called Polaris. Okay. Oops. Still have that up, huh? Okay. So this is Polaris right here. You see it's in the constellation Ursa Minor. And if you ever thought that little baby bear cubs needed to be even more cute, well, Ursa Minor has a ridiculously long tail. If you don't look at it too closely, you might think it's a squirrel. Totally understandable mistake to make right there. Polaris ends up being at the very end of the handle of what we call the Little Dipper, or it's at the end of the tail of the little bear right there. I have to admit, while I have no trouble seeing Polaris from my home, I could see Polaris in my backyard, or probably I'd be looking for my front yard. I have a very hard time seeing some of these other stars in Ursa Minor. It's just that the light pollution around where I live makes it very difficult to see them. I also actually have a hard time seeing those stars when I'm out at the Prairie Winds Observatory. The main reason why is because when I'm looking north, I actually get a lot of the light pollution from Champaign-Urbana when I look in that direction. So it makes it pretty tough to see. That said, though, I can always see these other two stars in Ursa Minor. Okay, there's for cod and there's kochab right there. I always actually remember to myself, if I'm in really dark skies and I'm having trouble finding Ursa Minor from Polaris, I want to actually curl right back towards the handle of the Big Dipper, and that helps me point the way to it. Over the course of a night, I told you that the Big Dipper is always going to be up, and it'll just look upside down at times. As we go a lot later, watch what happens to the Big Dipper and the Little Dipper. That's not going fast enough, so I'm going to jump up by an hour. Let's do this. There's it at 10 o'clock tonight. There's at 11. There's at 12 o'clock a.m. So there's midnight. And there's at 1 a.m. And there's at 2 a.m. right there. So you see that the Big Dipper is actually circling around Polaris over the course of that night. That's why the Big Dipper is so useful to us. The Big Dipper here in Champaign, most all of it stays up the entire night. Sometimes it's really low, I admit, but it's going to be up and you're going to be able to use it to point to Polaris, to point to the North Star at any time. And of course, Polaris is always going to be up as well. So you'll always be able to use that to help you point to due north. Now, why is it due north, you might ask? The reason is because when you think about Earth as a globe, directly above our North Pole, that's where Polaris is sitting right now, okay? So if you were standing on Earth's North Pole and you look straight up, you would find Polaris right over your head, okay? Where you're at, Polaris is not directly over your head, but it's going to be pretty high up in the sky, and you'll see it pointing towards the north. All right, so now it's actually 2 a.m. Oh my gosh, this is way past my bedtime. I actually see Waylena's favorite star there. I see her going nuts, but it's a good thing she's on mute, so we can't hear her at this moment. But she did shake her hands around, much like Kermit did on every episode of The Muppet Show. So that was good. All right, yes, she is doing the yay right there. We happen to be looking over in the southeastern part of the sky at a very fun constellation. But this constellation, in order to properly appreciate it, let's go up a couple more hours. Okay, there. Now I see the whole constellation. And now this is the sky at about 4 a.m. right here. Okay. This constellation being so low, you might not see all of these stars in your skies. But this should at least work for us. Okay, so I'm going to click on one of the stars here. I'll click on Waylena's favorite. There we go. The star's name is Antares. If you look at it really closely, you see it's got that kind of reddish color that might remind you of the wow. I'll eventually use the right word, of the planet Mars. And that helps you understand where its name came from. Ares is the Greek name for the god of war. Mars is the Roman name for the god of war. And so Antares means that Antares got named because of its comparison to the planet Mars. Basically, its name just means not Mars, which is just such a fun thing to say. Yeah, when you look up at that star, you can say, well, I'm looking at not Mars right there. Sure, yeah, not Mars. All right. Now, some people might ask, why would you want to compare this star to that planet that we were seeing back at 9 o'clock? It's 4 a.m. Why would we be looking for that? Well, look at the constellation it's in. It's in the constellation Scorpius. Scorpius, you might know about Scorpius because it's one of the constellations that the sun passes through. It's one of our zodiac constellations. If you want to see the sun's path through the sky, here is a line we call the ecliptic. The sun moves along the ecliptic over the course of the year, right there. So it runs through all those zodiac constellations, and the planets actually run right along the ecliptic as well. And every couple of years, Mars passes very close to the ecliptic, very close to the star Antares. So every couple of years, you can see Antares right there next to Mars. I don't think you'll actually mix the two of them up. For one thing, Antares always is twinkling very, very nicely, but it's still fun to see them in comparison to each other at that time. All right, so let's go ahead and turn that off there. Oops. All right, and let's go ahead and go a little bit later because we've got a couple more planets to show you right before the sun comes up. We're going to go 1 hour later. All right. Oh, there they are. Okay, so this is at about 5 a.m. We're seeing very low in the eastern sky, and we've got a couple of objects that are just barely rising. I think I'll click on the one that's a little higher up. It's a little dimmer right now, and I'm not going to give it away. I will click on it first, and then you folks will get a chance to see it. All right, so we'll center on it, and I'm going to zoom in, and you'll be able to see what it is. Oh, there it is. Okay, so when you see that ring system, that gives it away very nicely. This is a wonderful object to see whenever you've got a telescope. You are looking at the planet Saturn right there. If you've got a really, really nice telescope, you might actually even see that gap in the rings as well. We've got so many wonderful pictures of Saturn that we can see because we had a spacecraft orbiting around Saturn for over 10 years. Its name was Cassini. And it is probably one of the reasons why I very much sympathize with John's preference for the planet Saturn right there. Saturn is a great planet to look at through a telescope. I gotta say, if Earth weren't so habitable, I would love to just stare at Saturn up close every night. That would be a good second place favorite right there. But I've got to show my bias for the planet that I'm actually able to live on. Okay, that's just how it goes. Earth is great. So let's go ahead and show that other planet that we see over here. Maybe you know which planet we're going to be going for because I already talked about how Venus and Mercury are not visible. You already saw Mars. This one is a really nice bright planet, and that's because of how big it is. But let's go ahead and see what we're looking at. All right, we've got it in here. Just like Saturn, we see a number of moons orbiting around this planet. And let's get a nice big view of it. There we go. So with this one, you see a lot of those same stripy patterns there. We're looking at two gas giant planets, Saturn and this one. This is the planet Jupiter. Those stripes there, we call those belts and zones. Unlike Saturn, Jupiter has some extremely colorful belts and zones going on with this planet. Why it's so colorful? We're actually not totally certain. One major factor is because there are 3 different chemicals that can condense to form clouds in the atmosphere, but there seems to be some other contributing factors, other chemicals that are causing these neat colorations that we can see there. We've got to learn a lot more to get a better sense of this, so we send a number of missions to Jupiter. There's actually one orbiting around Jupiter right now. The name of that spacecraft is called Juno, and what's different about Juno from the previous missions that have flown to Jupiter is that Juno is actually flying over the north and south poles of the planet, giving us views that we have never seen before. We love looking at those images of Jupiter from Juno because they're just showing us some perspectives of this planet that have never been seen before. It's just quite amazing to see. Okay. And then these moons that you can see here, 4 of them are easily visible whenever you have a small telescope. You can see them bounce around Jupiter from one night to the next. Let me see if I can bring up their names here. Oh, that gives us a lot more names than usually I'm used to. You've got Callisto, Ganymede, Europa, and Io. All 4 of those you can see even in a very, very small telescope. And from one night to the next, you'll actually see them change their positions around Jupiter right there. Look at that. Okay. Oops. There we go. Back to today. And Galileo actually saw these moons around Jupiter when he first started looking at Jupiter with his telescope that he had built back in 1609, 1610. And this actually was quite surprising, and it actually eventually led him to understand that the sun could not possibly be orbiting around Earth because we were seeing other objects clearly orbiting around Jupiter. It didn't make so much sense for Earth to have to be the center of the universe because these 4 moons clearly didn't have Earth as the center of their universe. And so in Galileo's honor, those 4 moons are named the Galilean moons. Okay. All right, let's see here. I'm going to turn off those labels because they can get in the way, in my opinion. Thank you so much, Waylena, for sharing that link to the Juno mission, by the way. It's just a feast for the eyes, so I encourage you to look around on there. You might find a desktop wallpaper while you're at it. Okay, so what time are we at right now? Looks like it's at about 5 a.m. Well, let's go ahead and go a little bit later now. And there we go. Oh, here, I think I went a little too late. I wanted to show you just the last views right before dawn so you could see what the sky looks like at that time. So as you get closer and closer to sunrise, notice that most of your sky, you lose almost all of your stars. Pretty much the last thing you'll see before the sun comes up will be Jupiter. You might catch Saturn at about 6 a.m. You'll probably catch this bright star over here. This is one we love to talk about in the spring because notice you can actually still see the Big Dipper with these amplified images. And with the Big Dipper's handle, notice that the handle is kind of curved. And we have a really nice way to remember this star because we can say that this is curved like an arc, and you follow the arc to Arcturus. Okay, so that really bright star Arcturus there is going to be visible right before dawn as well. Okay, it's a very bright star in your evening sky. Not as bright as Jupiter, but still always worth taking a look at. So I think, if memory serves, yeah, I'm looking over in the western sky at this moment. All right, let's go ahead and let the sun come up now. So as the sun comes up, if you look really closely at it, you're probably not going to be able to see Mercury because Mercury will be coming up right before sunrise. Yeah, actually, there it is right there. You would not be able to see that very easily at all. But there, now the sun has come back up. Looks like it's up at about 6:30 in the morning. All right. Well, so folks, yeah, what we've done is we've been up all night. We've seen a few objects. And I gotta say, I think for Barbara's sake, I really should go through the trouble of actually showing you the Andromeda Galaxy. But with the Andromeda Galaxy, it's not a great time to see it right after sunset. It's really tough to catch it then. So I think instead of that, just before I end our show, maybe I should bring up one of my favorite photographs of the Andromeda Galaxy instead. I'm going to show you folks one more website. This is Astronomy Picture of the Day, and I'll show you exactly how I find it. So we'll get into the weeds of how I Google this website, just in case I can't find it. So Astronomy Picture of the Day, you can type in APOD into Google to find this. There it is. This is a website that's been around for 25 years. That is not the Andromeda Galaxy, but it's a worthy alternative. And they actually put up an image of Ingenuity on the surface of Mars yesterday. The reason why this one has such an odd color is because they want you to take out all your old 3D glasses that you had from those movies 50 years ago and put that up on the screen. It's meant to make our little flyer here look in 3D. It's a pretty neat image there. All right, so let's type in Andromeda Galaxy and see what amazing photograph we can find here. All right. Let's see what we can find. This is a really neat photograph. I love these sorts of images. This is not one single photograph. This is 2 images superposed atop each other. So there's this lovely picture of the Andromeda Galaxy here and all of these stars that we can see in the Milky Way around it. And then, of course, you've got the moon right there. Now, you've all seen the moon in the night sky, of course. But what this image tells you is that the Andromeda Galaxy is actually wider than the moon is in the sky, okay? If you ever look at the moon, the way you can tell how big it is put your arm out at arm's length like this, and you see my finger there now in the camera. When you have your finger out at arm's length in that fashion, you'll be able to see that the moon is actually smaller than the width of your fingernail, okay? And the same cannot actually be said for the Andromeda Galaxy. The Andromeda Galaxy will actually be wider than that, Okay, it's much wider than that in the sky. You just can't tell that very well because of how dim the Andromeda Galaxy is. The Andromeda Galaxy is barely visible to the naked eye. You need some pretty dark skies in order to see it. I've seen it a few times out at the observatory there, but it can be quite difficult. Okay, so you'll be forgiven if you can't see it yourself because of how dim it is. But yeah, this was just a cool way to visualize those relative sizes that you see for them in the sky. Of course, one of these is a lot closer to us. The light coming to us from the moon gets here in about a second, whereas with the Andromeda Galaxy, that light took over 2 million years to get to us. Okay, yes, thank you, Barbara. Home sweet home. That's fantastic. Thank you. I'm laughing at my mistake right there. Excellent. Okay, folks. Well, that is your tour of the night sky. Those are some of the highlights. If you want to stick around for the next 6 hours, I can show you everything I want to share. No? Okay, that's fine. Well, either way, I'm happy to take any questions that you might have. If you really prefer to ask your questions using your microphones, let us know and maybe we can unmute your microphones in one way. Or you can just type the questions into the chat. But I hope you've been enjoying this so far. Waylena, was there anything you wanted to share? I see you've got Jupiter in your background.
Yeah, yeah.
Let's go ahead and I'll stop my share and I'll put you on Spotlight. How about we do that instead? There we go.
There you go. Yep, this one was from October of 2019 from the Juno mission. And seriously, you go to that website and you'll emerge hours later. It's just incredible rabbit hole to fall down. Just the images are amazing.
Excellent, excellent. Now, there's a couple of questions and also suggestion in there as well. So Barbara asks, do the gas giants such as Jupiter have a core? I would say that yes, we call them gas giants, but at the very center, there is a hard candy shell. There is actually a rocky core there. In order for them to be able to have held on to that gas when the planet formed, it had to get enough rocky mass first in order to hold on to it. Now, it's not all rock that it was able to acquire at that time. It was also far enough away from the sun so that some lighter chemicals like water, carbon dioxide, ammonia, methane, all of those were actually cold enough to be solid. So it actually had fallen on to that forming planet like snow, and that actually helped out as well. So just above that rocky core, there is a layer of those lighter materials. Okay. Laura asks a great question about the colors of the planets. So you saw the color of Jupiter in these images. You see that Jupiter has a lot of colors to it. You saw how Saturn looks kind of yellowish. You saw how Mars looks kind of reddish. When it comes to Venus, Venus's clouds, it has a very thick layer of clouds around it. It has a much thicker atmosphere than Earth's, even though it's a very similar planet otherwise. Those are a pretty yellow color, I would say. Yellow or beige. What would you use a different term to describe it, Waylena?
No.
Okay.
Yellow beige, pretty good, yeah.
Okay. And then when you've got Mercury, Mercury is actually very similar to Earth's moon in color. They're very dark worlds. In some ways you might describe it as black, but when you look at it in pictures, it's a very just dark gray. Okay. And then if you look at some of the other planets like Jupiter that have very thick gaseous atmospheres, both Uranus and Neptune have blue hues to them. Neptune is a deeper blue, more of an azure color, whereas Uranus is kind of a blue-greenish color, like cyan in a way. Okay. Oh, okay. So that was actually Ellie asking that question on Laura's. Got it. Thank you. Okay. There we go. Yeah. And then So let's see here. There's, oh yes, let's bring up Jeff's comment. Jeff is mentioning that spring, even though the Andromeda Galaxy is setting pretty quickly after sunset tonight, it is a great time to look for lots of galaxies. He's absolutely right about that. Maybe some of you remember that cool image of a black hole that you saw a couple of years ago. That is a galaxy that is found within the Virgo cluster. The Virgo is a cluster of galaxies found in the constellation Virgo, which you can see coming up a little bit after sunset tonight. Okay, so if you have a telescope, that's a good place to check out a number of galaxies. The constellation Leo has a number of nice galaxies. There's actually a famous Leo triplet right there that would be good to catch. And near both of those constellations, the Coma cluster is up there too. You can find a couple of them there as well.
We featured the Leo triplet last week.
That's right, because you had a whole galaxy themed show to talk about. That's
so
right.
Check that out on YouTube.
Yeah. Yes. For more information, stop watching this and go watch our other show.
Hey, Eric, do you still have Stellarium handy?
I did
there's
not
a rabbit.
It. I have it
There's
up.
a rabbit in the sky.
That's a great point. All right. How about I go back to now and show you exactly where you'd find that bunny. All right. So let's share our screen one more time here. Okay. So I think I'm back at this moment. This is the sky now, 7:53 p.m. You start to see Orion showing up. I'm going to go just a little bit later. There we go. Okay. And so we had Orion, and I will bring back up that lovely artwork. There's Orion. There's the dogs. And I said dogs means I have to show the other dog. There's our other dog. There's Canis Minor. And just below Orion, you see a couple of stars right there. Let's click on one of them and see what pattern shows up. Lepus. Lepus or Lepus. Do you pronounce it Lepus? I don't remember. This is the Latin word meaning rabbit. So you could imagine that Orion and his dogs are hunting rabbits, just like Elmer Fudd. Okay. And so there's, you see Lepus trying to get away from that big dog right there. Okay, so there's your Easter bunny. All right. Eggs. I don't know about other eggs. I got to tell you though, when you see a nebula like the Orion Nebula, there are lots of areas you can't see them actually in the sky. You can't see them with visible light, but inside that gas and dust, there are some very dark clouds, and those clouds, some of them are collapsing to form stars. And when you see pictures of them, they actually kind of look like little stellar eggs. So there you go. There's one way to describe that. I wonder if on Astronomy Picture of the Day, I could find a picture of that. Let me see if I can find a couple of protostars. That's the technical term that we give for them. All right. Oh, that's not a bad, no, that's not one. Darn. I'll just sit here looking at a website forever, and I'll come back to you folks now. All right, we got a live show here. Let's see here. Yes, thanks for the clue there, Jeff. That's great. I'll look for Herbig Haro objects. Let's see if any of these will give us what we're looking for. There's that same thing there. It just wasn't as evocative as what I was hoping for, and that's why I didn't go with that first one. But let's see what we can find here. Yeah, the funny thing is, the reason why you can't see these things obviously in most images is because in order to catch this stuff, you actually have to find it with infrared radiation. Okay, NASA is trying to launch a telescope. Maybe it'll go up this year, maybe it'll go up next year, called the James Webb Space Telescope, that will be doing a lot of observations of this type, looking in infrared. And among the things they'll be able to see, they will be able to see these forming stars inside of these nebulae. Okay. Yeah. I'm not seeing the obvious little stellar eggs there. I will have to make a much deeper dive into finding one of those there. Yeah, I knew which one we were talking about, so that's all right. I will do this instead. I'm gonna have to. I'm going to do something a little silly here. I'm going to actually go into the online textbook that I use for my astronomy class because I know there's a picture in that.
Oh, that's it. That's it. We're in for it now. We're in for it now.
You got to stop me. Stop me before I get too far into this. I had
As we're close to wrapping it up, I'll go ahead and show the space cats.
Okay.
That I'm wearing.
Well, then I will make sure to put you on spotlight then.
They keep disappearing into the planet.
Oh, nice. Yeah, it's always tough to catch it when we've got the stuff in the background.
I have a real life space cat that's behind me, but she's sleeping, so she's not coming out to help me.
No, not at all. Yeah. All right. That's fine. Pardon me, folks. I'm sorry about that. That self-distraction there. But yes, I'm glad Jim was able to enjoy the space cats, and Ellie seems to have a lot of space cats too. That's all right. You just make sure those space cats are well fed. That's all I ask. Oh, and trust me, if they're not well fed, they'll let you know. Although I hear in space, nobody can hear you meow. All right. Perfect. 6 space cats. Oh my gosh, that's a lot of space cats. Okay.
Well, thanks everyone for joining us. This was so much fun. Still looking forward to the day when we can all get together again in person in the planetarium. But for now, we're making do and having a lot of fun with these programs.
Oh, absolutely. Yeah. And we're always happy to take requests for things that you want to see in a future show. We'll have another show in 2 weeks. So it will still be spring. So it'll still be Spring Prairie Skies. And if you miss one of our shows, remember to go onto the YouTube channel. We try to upload those pretty quickly. We're all caught up with that. Yes. And of course, maybe we'll keep doing shows and we'll have to get a fun setup so that Waylena is always debuting a new Space Cat shirt. But yeah, thank you all for joining us and have a wonderful rest of your day.